Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. So in the previous class, we have been discussing about the chapter Calorimetry, and in the last class we have discussed about the various phase changes taking place. We know that in general there are three states of matter: solid, liquid and gas, that we commonly see around us. Any subject, any object can be found either of these three states. So we have seen that the conversion of solid to liquid is known by one name, whereas the conversion of liquid to solid is known by the other name. Likewise, each and every conversion has certain name associated with it. So we have learned the name of those processes, and let me just speak to you about one matter. Do you know what is common in all these processes? That when liquid is converted into gaseous state, it is known as, I think you all know by now, it is known as vaporization, isn't it, or boiling. Whereas when a solid changes into liquid, what it is known by? It is known by the name solid changes into liquid is known by the name melting or fusion, isn't it? So do you know what do you can, or any of you can guess that what is the common thing in all these processes? See, whenever there is a phase change, I said whenever you want to raise the temperature of a certain body, you give certain amount of heat, and for that the heat given is m c delta T, whereas m is the mass of the body, c is the specific heat capacity, and delta T is the change in temperature. If you want to increase the temperature, you need to give or supply heat to the body, and if you want to decrease the temperature, you need to take away the heat from the body. So we have already known this. And during a phase change, do you know during a phase change what is common? During a phase change, any kind of phase change, it may be solid to liquid, liquid to gas, or gas to solid, anything. During a phase change, what happens? The temperature remains constant. Phase change, temperature remains constant. Temperature remains constant. Okay. So remember this thing. Temperature remains constant. Whatever phase change may be taking place, one thing is for sure, that the temperature during the change of the phase remains constant. Okay. So that is why the heat that you are supplying to a material during its phase change is known as latent heat. What it is known by? It is known by the term latent heat. Latent heat. Now this latent, the term latent itself has a meaning of hidden. Okay. This term latent has a meaning of hidden. So as you know that temperature change is actually a parameter to measure the heat given or heat taken out. Okay. So whenever there is no temperature change, we tend to guess where the heat is going. We think that heat is being applied or supplied to the body or taken away from the body, but there is no change in temperature. So it looks like as if the heat that you are giving to a substance while its phase is changing, or taking away from a substance while its phase is changing, is tending to be hidden, or it is going nowhere. So this kind of heat is called the latent heat. The heat that you give to a body while you are changing its phase. Okay. So, and when this heat, latent heat that you are calculating or observing, when you consider it per unit mass, then it is called specific latent heat. Okay. So this latent heat, when you consider it for per unit mass of a substance, per unit mass of a substance, okay, then it is called the what it is called? It is called the latent heat. Okay. Specific latent heat. Specific latent heat. As in case of temperature rise or temperature fall, we talked about specific heat capacity. Similarly, for temperature rise or fall, it is for phase change of a substance, the heat per unit mass is considered to be as the specific latent heat. Okay. So for while you are changing the phase of a substance, the heat that you need to give in or take away from an object is called the latent heat. So the amount of latent heat that you give, okay, so the heat required to melt or freeze or vaporize a substance or condense a substance is equals to Q equals to m into L, where L is the specific latent heat. by A is the specific latent heat. So this is the formula for phase change of a substance. The heat given or heat taken out for the phase change of a substance. So this is specific latent heat. Specific latent heat, L. Okay. So I think the concept of specific latent heat is clear to all of you. Okay. Fine. Now, so when you are while solving the problem, when you are seeing that there is a need for change of phase, okay, so apply this formula Q equals to M, and when you see that there is only a rise in temperature or fall in temperature, in this formula Q equals to MC delta T to find out the heat. Okay. Now quickly moving on. Now after this we will be discussing about the phase change of water. Okay, you know water has a very unique characteristics. I think all of you have noted these things. If not, please pause the video and note it down. Okay, else you can move on. Now see, water, for when you are discussing about water, water has some unique feature. Okay, what is the unique feature? You must all be knowing this by now. Water, what happens when you give heat to water, it expands. Okay, fine, no problem. When you cool water, it contracts, that is also okay. But do you know that water has a reverse characteristics within a certain temperature range, and that is known as the anomalous behavior of water. Okay, what is the anomalous behavior of water? Do you know? See, when you cool water, actually it should contract, that is its volume should decrease. Obviously it happens, but this happens up to, so just let me write down the heading. We are talking about anomalous behavior of water. We are talking about anomalous behavior of water. So what is this anomalous behavior of water? See, when you are cooling water, okay, when you are cooling water, it contracts. Obviously its volume decreases, but up to certain temperature. What is the temperature? That temperature is 4 degrees centigrade. So up to 4 degrees centigrade, when you cool water, it contracts as normal. It contracts as normal. Okay. So up to 4 degrees centigrade, water contracts. Okay, water contracts, isn't it? Or so water contracts. Okay. After that, when you cool further from 4 degrees centigrade to 0 degrees centigrade, what happens? Water expands instead of contracting. So after, that is from this 4 degrees centigrade to 0 degrees centigrade, water instead of contracting, what happens? Expands. Instead of contracting, it expands. Okay, it expands. Fine. Okay, very good. It expands. Now this is actually abnormal. Okay, the word anomalous means abnormal. So this is obviously abnormal behavior. It should have contracted, but it expands. So this is the anomalous behavior of water, and this takes place up to 0 degree centigrade. And after at 0 degree centigrade, water freezes into ice, and after that whatever normal phenomenon exists, that is while cooling it contracts, and while heating it expands. So on the contrary, when you heat water from 0 degree to 4 degree centigrade, it contracts instead of expanding. So if I just say that I am heating water from 0 degree centigrade to 4 degree centigrade, okay, so what will happen? Water will contract instead of expanding. Okay, instead of expanding. Fine. So this is the anomalous behavior of water. Okay. So this was just a little bit of recapitulation of your previous knowledge. Okay. Now, so this is just a recapitulation. So now we will be moving on to the next topic. That is what happens when we will be looking graphically about the temperature rise of water with respect to its change in the time. Okay. Okay. So let us move on to the graphical analysis. Okay. So if you have noted it down, please, we are moving on to the next topic, and if you have not noted it down, then please pause the video and note down the concepts. Okay. Although this is actually not a part of your class 10 syllabus, but it is an important concept, so I just thought I should recapitulate it. Okay, fine. Now quickly moving on to the next. So now if I say what happens when I hit ice, when I start hitting ice from say minus 10 degrees centigrade and hit the ice until its temperature reaches say 110 degrees centigrade, what does happen? Okay, so we are actually plotting the temperature versus time graph of a certain amount of ice. Okay, we are starting from ice, so just let me plot the graph. Okay, just consider it a little bit from the downside, it will be easier to explain. Okay, so this is the time graph, okay, and this is the temperature graph. Okay, so this side represents the y-axis, represents the temperature, okay, and the x-axis represents the time. Okay, see now if I consider say ice, some certain mass of ice at 0 degree centigrade, certain mass of ice at not 0 degree centigrade, let us consider at minus 10 degree centigrade. Okay, so you have considered certain amount of ice at minus 10 degree centigrade, so this is minus 10 degree centigrade. Okay, this graph is not drawn according to scale. I am mentioning it again and again, the graph is not drawn according to scale. I am just trying to clear the concept. Okay, so when you start hitting, what happens when you start hitting ice at minus 10 degree centigrade, its temperature slightly or slowly starts increasing. So with progress of time, actually the temperature keeps on increasing. So the graph will be something like this. It will be this line represents, this x-axis represents 0 degree centigrade. Okay, now when you start hitting ice from minus 10 degree centigrade, it's slowly the temperature increases and reaches this point. Okay, reaches this point. Fine. Okay, now whenever it is reaching this point, particular point, it reaches the 0 degree centigrade, that is the melting point of ice. Okay, so now we know that during phase change what happens, the temperature of ice will not change until the total mass of ice is wholly converted into water. Okay, so for a certain time being, the graph will be like this. Okay, like this. Fine. Now up to this point, say the water has melted, the ice has completely melted into water. Now from this point again the graph will start rising, as because the whole ice has been converted into water. Now the temperature of water rises slowly as we heat it, so it will keep on rising like this, and with time the temperature increases. Now say up to it will keep on increasing up to which temperature? Up to the boiling point of water. So say this is 100 degree centigrade or boiling point of water. Okay, now when it reaches the boiling point of water, remember again the temperature remains fixed for certain time. The time passes on but the temperature does not change. So for this range again the temperature remains fixed, and after that what happens, when the total mass of water has been converted into steam or vapor, the temperature again starts rising and say it goes up, so above 100 degree centigrade. So this is the graphical analysis for the temperature time relation while you are heating a certain mass of ice. Say it is from the minus 10 degree centigrade. Here we are taking it from minus 10 degree centigrade. So if I just mention the points, say consider this is point A, this is point B, this is point C, this is point D, this is point E, and this is point F. Okay, so just try to understand that from point A to B, this part is actually only ice, From B to C, there is a mixture of ice and water. Okay, so here ice and water both are present. Okay, then after from the C, the total ice has been converted into water. So from part C to D, this part is only water again, So here there is no mixture, only water. And again in the part D to E, here both water and vapor exist simultaneously, as because within this time there is both vapor and water present, at point E the total vapor water is converted into vapor, and then after the point E what it is there is totally vapor. So remember these steps. Now often in the exam this graph is given and the various data points have been asked, so please remember this graph carefully. Okay, just a little bit of say. Okay, so here is the temperature. I have been missing it out, sorry to. Okay, please take a note of it. The y-axis is temperature. Okay, so now it is clear. Okay, so this is the graph. Now I think the concept is clear to all of you. So this is the conversion of ice into water and then into vapor. Okay, so with this we come to an end to the chapter calorimetry. I think in the next class we may be doing some problem, or we can also give the numerical problems, solution of the numerical problems in the audio classes only. So hopefully I will be doing some the classes on the numerical problem and then move on to the next chapter. Okay, so with that we will be ending today's class. Till then, till the next video, please do study well, and please, if you have any doubt, any query, then you can mention in the comment section. We will be trying our very best to solve your doubts and queries. Till then, so take care, goodbye, thank you.